Imagine a world so alien, so extreme that it makes outer space feel almost familiar. We're talking about a realm of just unimaginable pressure, total darkness, and these bizarre life forms that really challenge everything we thought we knew about survival. This is the deepest place on Earth, the Mariana Trench. It's a frontier, honestly, far less explored than the surface of Mars.
It's truly a realm of, well, profound mystery. And what's becoming increasingly clear is that while this might seem like a purely scientific thing, a quest to find weird creatures in the planet's last great wilderness, it actually opens up a much bigger story. The deep ocean isn't just some repository of strange animals. It's rapidly becoming a treasure trove of vital resources and, maybe more importantly, a quiet yet pretty aggressive new arena for global power dynamics.
Okay, yeah, let's dive in then. Our mission today is basically a shortcut to understanding this really complex, often overlooked, but profoundly important topic. We're going to take you on a journey down through the ocean's deepest layers, encounter creatures that are truly wild, discover incredible resources hidden way beneath the waves, and then really zero in on the high-stakes global race that's unfolding silently way below the surface. By the end of this deep dive, you'll get why this isn't just a science story, but one that could profoundly transform, geopolitics, resource control, even global security for decades to come. So, okay, to really grasp what's happening down there, we need to take a kind of virtual descent. You're going to feel the pressure build, you'll witness the light just disappear, and you'll meet some creatures you just won't believe exist on our own planet. So our first core question really is, how deep is the Mariana Trench? And, what actually lives way down at the bottom of the ocean? Let's start our descent into the abyss.
Right. The Mariana Trench is this immense underwater canyon, like a geological scar stretching over 2,500 kilometers across the western Pacific, just east of the Philippines. To put that into perspective, that's roughly the distance from New York City out to Denver. So, huge. This massive kind of crescent-shaped chasm isn't just deep. It is, without question, the deepest known part of the entire ocean. It formed through subduction, where one tectonic plate gets forced underneath another, creating this colossal tear in the Earth's crust.
And when we talk about deep, we're talking truly unfathomable depths, like nearly 11,000 meters down. That makes it considerably deeper than Mount Everest is tall. It's hard to even picture. Imagine Mount Everest, right? Flip it upside down, and its peak would still be thousands of feet below the surface. To reach the very bottom, you have to travel through the ocean's entire water column, and you experience conditions that are, frankly, just mind-boggling. Down there, there's absolutely zero sunlight, none. And the pressure is so crushing, it's almost impossible for us to really comprehend.
Indeed, yeah. The conditions are so extreme that life down there has adapted in these extraordinary, almost alien ways. As we descend, we pass through these distinct vertical layers, each with its own characteristics and unique inhabitants. It really showcases the incredible resilience and adaptability of life on Earth. These zones are defined mostly by, well, light, or the lack of it, and the escalating pressure.
So let's start at the top, the familiar world we know, the photic zone, or it's sometimes called the epipelagic zone. This goes down about 200 meters from the surface. Here it's warm, it's bright, teeming with sunlight. This is the part of the ocean we know, right, where we swim, surf, snorkel. Think vibrant coral reefs, vast schools of colorful fish, all the abundant, familiar life you kind of associate with the ocean. It's all driven by photosynthesis. But as you go deeper, things change dramatically.
Right. Below 200 meters, we transition into the twilight zone, or the mesopelagic zone, which stretches down to about 1,000 meters. Here, sunlight rapidly fades. It becomes this dim, sort of ethereal glow before it just disappears entirely. And crucially, the pressure starts to build significantly. We're talking up to 10 times what we feel at sea level. That's enough pressure to crush most things that live near the surface. Animals here have to adapt, or they just won't survive the descent.
And the creatures here are already starting to get, well, bizarre. Like, consider the oarfish. This silvery, serpent-like giant. It can grow longer than a bus. Sometimes they wash ashore after storms, looking like something straight out of a sea monster legend. Then there's the sea angel. It sounds lovely, but it's this delicate, transparent kind of winged slug that flutters through the fading light, using these tiny wing-like fins. As the sunlight disappears and the pressure climbs, animals adapt in fascinating ways. A lot of them lose their color, becoming translucent or silvery to blend in. Others grow these oversized eyes, almost cartoonish, trying to catch every last photon of light. Or they evolve soft, flexible, sort of gelatinous bodies that won't collapse under the increasing weight of the water. It's really a testament to life's ingenuity when things get tough.
Absolutely. It's a profound transition zone where the familiar really gives way to the truly alien. The physiological and anatomical adaptations we see here are just critical for understanding how life can persist under increasingly difficult circumstances. And that's a theme that only intensifies as we go deeper, demanding ever more specialized ways to survive.
And we are going deeper. At 1,000 meters, you enter the midnight zone. It's also called the bathypelagic zone. Here, there is absolutely no sunlight, none at all. The only light you find down here is what the creatures themselves make, that captivating natural glow, bioluminescence. Animals here look like something straight out of a sci-fi movie. They've got glowing lures, transparent bodies, and often these disproportionately huge mouths to snatch any rare meal that floats by.
Yeah, one creature that truly embodies the sort of eerie and powerful nature of this zone is the Magnapenna squid. This thing is unsettling. It has incredibly long, spidery arms that can reach over 6 meters. That's like 20 feet. They just dangle like puppet strings in the dark as it drifts, waiting to, ensnare unsuspecting prey. It's genuinely the stuff of nightmares down here. And the pressure in this zone, it builds to 100 times what we feel at sea level. That's about 1,500 pounds on every single square inch of your body. Try to imagine a full-grown elephant pressing down on just your fingertip, but from every direction all at once. Yet somehow, life persists.
One of the most famous creatures often linked to this zone, though maybe misunderstood, is the blobfish. In its natural habitat, way down there near the top of the midnight zone, it actually looks like a perfectly normal deep-sea fish. It's streamlined, adapted to that intense pressure. But when scientists bring it rapidly to the surface, all that external pressure just disappears, right? And its gelatinous body loses all structural integrity. It expands into that sad, deflated, almost comical shape you've probably seen online. It's a perfect, if stark, reminder of just how extreme the pressure really is down there, how life's form is entirely dictated by its environment. Its appearance at the surface is just an artifact of us pulling it out, not its true nature.
That highlights beautifully how an animal's appearance is just intrinsically linked to its environment. Its normal functional form is totally different from the one we usually see, which is, like you said, just a consequence of removing it from its natural high-pressure home. It really underscores the fragility and specialization of these deep-sea ecosystems.
But the descent keeps going. At 4,000 meters, you reach what's called the abyssopelagic zone, often just called the abyss. It's profoundly cold, absolutely dark, and eerily quiet. Life here is sparse, sure, but it's not absent. And here's where the seafloor, which might look totally barren at first, might surprise you. At first glance, it just looks like plain, featureless mud stretching out into the gloom.
That mud is incredibly deceiving, though. It's actually a living archive and a really critical part of the planet's health. Have you ever wondered what happens to, well, everything in the ocean when it dies? The fish, the sharks, even the tiniest plankton. Eventually, everything that lives up above sinks down. Some falls as waste, some as tiny particles digested and then expelled by other creatures. Over millions of years, this continuous shower of organic matter drifts down, settling onto the seafloor in what scientists call marine snow.
Marine snow, right? Layer by layer, this stuff accumulates, forming this soft, carbon-rich mud. In some places, that mud is over 1 kilometer thick, more than 3,000 feet, composed entirely of the remains of everything that once lived above. These layers don't just preserve the ocean's history, they also trap enormous amounts of carbon. It effectively turns the deep sea into one of the planet's most powerful natural carbon sinks. It's like this slow-motion burial of the past that profoundly impacts our climate today.
Yeah, and even with all that marine snow piling up, life down here is incredibly scarce. Most creatures survive on just scraps. Adapted to a world where abundant food is a rarity, they tend to have low metabolic rates, slow growth, and often really long lifespans. But every so often, something incredible happens, something massive sinks, and when it does, it completely transforms everything for the local ecosystem.
You're talking about whale falls, right? Those are truly incredible events. When a dead whale, maybe weighing tens of tons, falls all the way to the seafloor, it becomes this enormous magnet for life. Deep-sea scavengers like sleeper sharks and hagfish, they move in within hours, consuming the soft tissues. Then, a whole succession of specialized organisms follows. Things like bone-eating worms called osedacs, various snails, bacteria that thrive on the whale's fats and cartilage. A single whale fall can support an entire, albeit temporary, ecosystem for years, sometimes even decades. It's this massive burst of energy and opportunity in a place where resources are usually so precious.
Exactly. And we see not just general scavengers, but incredibly specialized organisms like those tiny hair-like worms, oxidacs. They literally drill into the bones to extract nutrients. Life down here just doesn't waste a single moment when such a rare, massive opportunity comes along. Yet surviving in the abyss still isn't easy. The water temperature is just above freezing, a constant bone-chilling cold. And the pressure is crushing more than 400 times what we feel at the surface. That's like trying to balance 7 full-grown elephants on your fingertip, feeling that immense weight pressing in from all sides, relentlessly.
And still, we go deeper, beyond the abyss.
Oh.
You're now deeper than 6,000 meters below the surface. This is the Hadal Zone, named after Hades, the Greek god, ruler of the underworld. This is real trench territory from here on out. The Hadal Zone primarily exists within these deep ocean trenches, like the Mariana Trench itself. Very few submersibles can even get this far down, let alone operate effectively.
The pressure in these extreme depths is just staggering, more than 600 times what we feel at the surface. To survive that, a submersible needs a near-perfect, pressure-proof design, often using incredibly strong titanium alloys or specialized ceramics. Only a handful of submersibles on Earth have ever actually achieved this engineering feat, which makes any visit down there a monumental undertaking. It's really a testament to the cutting edge of material science and mechanical engineering to even reach these depths, let alone do complex work there.
And finally, at nearly 11,000 meters, we hit the very bottom of the Mariana Trench, specifically its deepest point. That's deeper than Mount Everest is tall, with thousands of feet to spare. Here, the pressure is so intense, it would feel like 90 full-grown elephants pressing into every fingertip-sized area of your body, from all directions, all at once. But here's the truly incredible part, the answer to our question about what lives at the bottom. Life still exists.
Yes, life. Even at these unimaginable extremes, some of it in really strange forms, like giant single-celled organisms called xenophores. These are large amoeba-like creatures that filter food from the seafloor mud. They thrive under pressure that would instantly crush most other life as we know it. We also find specialized amphipods, these tiny crustaceans, and pale, delicate shrimp that kind of creep silently across the mud, all perfectly adapted to the crushing weight. Life here is rare, it's specialized, often slow-moving, but it's just a profound demonstration of life's tenacity. It really makes you wonder what else could be hiding in these trenches, doesn't it? We know life survives, but there's still so much more we just haven't seen. Maybe unique biochemical processes still waiting to be discovered?
Okay, let's stay at the very bottom of Mariana Trench for just a moment. As you mentioned, this underwater canyon stretches more than 2,500 kilometers. But not every part of it is the same depth. Near the western end, there's this distinct spot that plunges even deeper. It's like a pit within the trench itself. So if the Mariana Trench is the deepest part of the ocean, our next question is, what exactly is Challenger Deep?
Challenger Deep is precisely that, the most extreme depth on Earth's seafloor. It simply doesn't go any deeper than this point. It represents the absolute physical limit of our planet's oceanic depths, a unique geological feature within the broader Mariana Trench structure. It's essentially a smaller, deeper subtrench, kind of a basin at the very bottom where the pressure really reaches its absolute maximum.
Wow. It was first reached way back in 1960 by a really daring team, the Swiss engineer Jacques Piccard and U.S. Navy Lieutenant Don Walsh. They made the descent in this steel sphere called the Trieste, which was attached to a massive float structure. That first dive, they only spent 20 minutes on the bottom, just 20 minutes, which is really a testament to the immense risks and the technological limitations back then. And then, for over 50 years, nobody followed, which is a pretty stark indicator of just how challenging it was.
Indeed, the technology, the funding, the sheer courage required, it meant these were extraordinarily rare feats. It wasn't until 2012 that the filmmaker and explorer James Cameron dove solo in his submersible, the Deep Sea Challenger. He captured some stunning footage, gathered crucial samples, and importantly, made it back safely. He really pushed the boundaries of what people thought was possible for a solo mission to that depth. And then a few years later, the explorer and multimillionaire Victor Vescovo, with his high-tech submersible, The Limiting Factor, made multiple dives. He collected really detailed data from the bottom, further showing that sustained access, while incredibly difficult, was actually becoming possible.
Right, but each of these missions, despite their incredible scientific and engineering achievements, had something crucial in common. They were rare, they were astronomically expensive, and mostly they were one-offs. They were expeditions, singular events. And that really sets the stage for a dramatic shift. Given the decades of difficulty and expense, you have to ask, what happens when a nation decides to fundamentally change that equation, to move beyond these one-off expeditions to something far more sustained, strategic, and repeatable? This is where it gets truly transformative, I think. For decades, deep-sea exploration was pretty much the domain of a few daring individuals and these bespoke, incredibly expensive custom-built machines. But one nation saw an opening, and they didn't just step in. They seem to have completely rewritten the playbook, fundamentally changing how deep-sea exploration is even done. So our next big question is, how exactly does China explore the deep sea? What's their approach?
Well, China's entry into this field really marked a profound paradigm shift. In 2020, they achieved a pretty significant milestone. They sent a team of 3 scientists right to the bottom of the Mariana Trench in their submersible, the Fendouge, reaching the deepest point. It was a remarkable accomplishment, no doubt. But what truly set their effort apart was that they didn't stop there. They immediately doubled down on their investment, showing this real commitment to continuous presence rather than just a singular achievement.
Right. That's the key difference, isn't it? Instead of just celebrating one big win and moving on, China invested more. They rapidly escalated their capabilities. Each new sub they designed was smaller, more advanced, and crucially designed not just for these one-off expeditions, but for repeated, sustained missions. This commitment to continuous, iterative development and deployment. It's just a complete game changer in deep-sea access.
And by 2024, China had moved beyond even these crewed missions, which are inherently limited, right, by human endurance, safety concerns, high operational costs. They shifted towards something far more ambitious: autonomous deep-sea robotics. This is where their strategy really starts to differentiate itself, paving the way for a persistent, expansive presence in the deep.
And this is where the groundbreaking innovation truly shines. Picture this. A robot, no bigger than a shoebox, dropped into one of the most hostile environments on Earth. No pilot on board, no fragile cable tethering it back to a surface ship for power or control. This tiny machine just crawled across the seafloor under its own power, gathered data, and came back intact. That moment, it marked a profound shift. It signaled that deep-sea access was no longer solely the domain of massive, expensive submersibles.
Exactly. It transformed deep-sea exploration from these rare, high-cost, high-risk human-crewed missions to something repeatable, scalable, and far more ambitious. This development allows for an unprecedented volume of data collection, mapping, observation. The implication here is pretty significant. If one tiny autonomous robot can do tasks that used to require a massive human-crewed sub, what happens when you deploy an entire fleet of them? This is really about establishing a continuous, low-cost presence that fundamentally alters the whole economic and logistical landscape of deep-sea access.
Think about it. China is developing a whole new generation of these deep-sea robots, small, highly autonomous machines that can glide through the water, crawl across the seabed, or even flex their way through tight spots. They're built for different tasks, right? From detailed mapping to sample collection. And crucially, they're designed to work together in coordinated fleets. This allows them to cover vastly more ground, more often, and at just a fraction of the cost of those big crewed submersibles. It's a distributed, persistent approach that, frankly, no other nation is currently matching in scale.
And this continuous, persistent presence allows for an unparalleled level of data collection, environmental monitoring, resource assessment, you name it. It's not just about one discovery anymore. It's about systematically understanding and eventually exploiting the entire deep-sea environment. And this capability immediately raises an important question. What exactly are they hoping to find with this advanced, persistent presence? What treasures lie hidden down there in the deep?
So yeah, let's transition from how they're exploring to what they might be after.
Yeah.
Because the deep sea holds more than just strange creatures and extreme pressures. It holds hidden treasures that could really reshape our future.
Indeed. Consider what scientists call cold seeps. These are areas on the seafloor where methane, hydrogen sulfide, and other chemical-rich fluids literally seep up from beneath the Earth's crust. They might not look like much, just maybe some shimmering water or patches of white bacterial mats, but these chemical releases feed entire ecosystems. We're talking mussels, clams, giant tube worms, all surviving without sunlight, living off chemical energy through a process called chemosynthesis. It's a striking contrast to photosynthesis, which is the basis of most life we know on Earth.
Okay, so what does this mean for China's deep sea strategy? These cold seeps, they aren't just fascinating biological curiosities, are they? They're like living laboratories, offering priceless clues. They show how life can thrive in the most extreme conditions, giving insights into resilience. They offer models for future energy systems, perhaps, exploring how chemical energy can be harnessed. And they even resemble environments scientists think might exist on some of the moons of Jupiter and Saturn, like Europa, which could harbor extraterrestrial life. So for a country like China, aggressively racing to control the deep and maybe even reach beyond Earth's confines, places like this are truly invaluable for both scientific advancement and, let's be honest, strategic advantage.
And that strategic value extends beyond just understanding life itself. It touches directly on resource acquisition. For instance, you might see something that looks like frozen snow packed into the seabed. But it's actually something far more unusual and potentially revolutionary, methane hydrate, often called fire ice. Which brings us to another of our key questions. What exactly is fire ice?
Fire ice, right. It forms when methane gas gets trapped inside this crystalline cage of water molecules, basically. Ice, but under extremely high pressure and cold temperatures on the seafloor. And yeah, if you dig it up and hold a flame to it, it actually burns. Scientists are intensely studying it as a potential massive fuel source, a vast, untapped energy reserve locked beneath the seabed. Some estimates suggest the energy stored in methane hydrates globally could exceed that of all known conventional fossil fuels combined. It's potentially huge.
But, and this is a big but, extracting it is incredibly complex and risky. Disturb the seafloor too much and you could trigger catastrophic underwater landslides, potentially even unleashing tsunamis. More critically, methane is a really potent greenhouse gas, far more powerful than carbon dioxide in the short term. Releasing large amounts of it into the ocean and atmosphere could have devastating, unpredictable consequences for the global climate. The very fact that we're even seeing, observing, and seriously contemplating extracting this resource at these depths just shows how far deep-sea exploration and ambition have come.
And it raises the next critical question. What other incredibly valuable resources might be down there, just scattered across these abyssal plains, those round, lumpy rocks you see scattered across the seabed in photos, often described as looking like small potatoes. Their true value is immense. So our next question, what are polymetallic nodules?
Those are polymetallic nodules, and inside them they contain essential metals like cobalt, nickel, copper, and manganese. These metals are absolutely crucial for building the modern world and especially for the future green economy. They are vital components for batteries and electric vehicles, for wind turbines, solar panels, countless electronic devices, everything, really. As global demand for these strategic metals just skyrockets and land-based reserves become scarcer or more difficult or politically tricky to access, the deep sea represents a potentially enormous, albeit highly controversial, supply.
Yeah, this immediately brings us to a crucial ethical and practical dilemma, doesn't it?
Yeah.
If these resources are so vital for our technological future, for transitioning to a greener economy, what are the implications of developing the means to extract them, especially in such an incredibly fragile and, let's face it, poorly understood environment?
That leads us directly to another critical point. How exactly does deep-sea mining work, and what are its consequences? The current proposed process is, well, conceptually straightforward, but technologically incredibly complex. It usually involves a large surface ship lowering a robotic mining vehicle, sometimes called a collector, down to the seafloor thousands of meters below. That vehicle then crawls along the bottom, essentially scooping up the top layer of sediment along with those potato-sized polymetallic nodules. Then everything collects mud, water, nodules, gets pumped back up through a riser pipe, often miles long, to the processing ship waiting on the surface.
You can already see the immense ethical tightrope we're walking here. On one hand, yes, these are resources critical for our sustainable energy future, for meeting the demands of a rapidly electrifying world. But on the other hand, we're talking about potentially irreversible damage to ecosystems we barely understand. As these collector vehicles crawl across the seabed, they kick up these massive clouds of sediment, known as plumes. These plumes can be vast, potentially smothering fragile, slow-growing habitats like deep-sea sponges and corals. And they can drift for miles, impacting a much wider area than just the immediate mining site, potentially suffocating organisms across huge swaths of the deep.
And it doesn't stop there. After the nodules are processed on the ship, the waste, the slurry of seawater, fine sediments, maybe traces of processing chemicals, gets pumped back into the ocean, sometimes at midwater depths, sometimes closer to the surface. This creates a second plume, adding to the environmental chaos. Many marine biologists and conservationists are deeply, deeply concerned about deep-sea mining because these abyssal ecosystems are just incredibly slow to recover. If they recover at all, it's due to the extreme conditions, the slow pace of life.
Right, recovery could take centuries.
Exactly. Centuries, even millennia, to regain original biodiversity, if ever.
Disrupting these deep-sea habitats could wipe out species we haven't even discovered yet, species that might hold keys to new medicines or scientific breakthroughs, and destroy habitats that took literally millions of years to form. And with no clear international consensus yet on how to effectively manage the waste, or rigorous independent oversight on where to put it and how to monitor its long-term effects, well, one thing is clear. We're charging to the deep without a full picture of the true ecological cost. Regulations are sparse, still being developed by bodies like the International Seabed Authority, the ISA, but ambition seems to be outpacing oversight.
And China sees that opening. They're not just observing or experimenting with deep-sea mining technologies. They're rapidly advancing their capabilities. They seem to be getting ready to extract, to claim, and to secure what's down there before potentially stricter regulations come in, or before anyone else does. They're making these long-term investments in a continuous, persistent presence, which goes way beyond just robots.
And that long-term presence isn't just about autonomous robots and mining vehicles. This brings us to another really fascinating and perhaps slightly unsettling development. What is China's underwater base?
Right now, China is reportedly planning to build a permanent base 2,000 meters underwater. This isn't some temporary research station. It's described as a sophisticated habitat designed for 6 scientists to live and work for up to 30 days at a time. It's truly like a space station, but strategically positioned on the ocean floor, designed for sustained human habitation and research in the deep. This is a monumental engineering undertaking that signals a very serious long-term strategic commitment.
And this kind of facility gives China something even more valuable than just minerals, doesn't it? It provides time. Time to test new tools and technologies right there, in situ. Time to continuously monitor the deep environment. Time to gain the kind of unparalleled operational experience that few others are even attempting down here. Access is just the beginning, right? What really matters is what you do with that access. China seems to be systematically building the tools, the knowledge, and the human expertise needed to operate effectively in the deep. Not just once or twice, but continuously.
Yeah, a permanent underwater base signals an unparalleled long-term strategic commitment. It's not just about what they might discover down there, it's about the sustained capability and presence they establish. It gives them an unparalleled advantage in this burgeoning frontier. This is how they're truly pulling ahead, by transforming exploration into repetition and then repetition into dominance, establishing this comprehensive operational footprint. The deeper you go, the less room there is for guesswork, and the countries that are investing now in the hardware and the research and the people, they're the ones setting themselves up to control what lies beneath.
And there's one more critical piece of infrastructure that lies hidden on the seabed. It's out of sight, yet absolutely crucial to the way our modern world functions. It's not rocks and resources, and I'm not talking about the creatures themselves. This is a cross-section of a deep-sea data cable. It might look like just plastic and metal, but inside are these hair-thin glass fibers carrying most of the world's internet traffic, your messages, emails, video calls, even this deep dive we're having right now. These vital conduits travel through these seemingly fragile lines stretched across the ocean floor. And despite their thick protective casings, these cables are surprisingly easy to damage. This raises a really critical question. Can undersea cables actually be cut?
Oh, absolutely. They are surprisingly vulnerable. While they're designed to be robust, they are definitely susceptible to damage. A single ship just dragging its anchor, commercial fishing trawlers, even natural events like earthquakes or underwater landslides can knock a cable out, and that causes widespread internet outages, significant economic disruption. In recent years, for instance, there have been reports of Russian ships operating with increasing frequency near critical undersea cable routes, places like the North Sea and other strategic areas. That's raised significant concerns about potential sabotage, maybe tampering. These aren't just passive infrastructure, they are the modern world's lifelines, the nervous system of global communication, trade, even military operations. And their fragility is a major geopolitical concern.
So imagine the implications if someone wanted to cut these cables deliberately, covertly. In early 2025, China reportedly revealed another deep-sea robot described quite literally as a cable cutter. Now, officially, its stated purpose is for repairing damaged undersea infrastructure, and that's a legitimate, even essential function for maintenance. However, a device with that capability could also, theoretically, be used to quietly disable critical data cables thousands of meters below the surface. Out of sight, out of reach, potentially without anyone noticing for hours or even days.
And this dual-use nature of advanced deep-sea technologies really demands careful, critical thinking about intentions and oversight. How do we distinguish between tools meant for scientific discovery or infrastructure repair and those with the potential for strategic disruption? While there is no public proof, let's be clear, that China's cable cutter has ever been used maliciously, the mere existence and capability of such a device is enough to fundamentally shift how nations think about the security of the deep sea and the vulnerability of global communications. Beneath the ocean floor runs the nervous system of the modern world. Essential data cables, critical sensors, military communication lines stretching across the seabed. They are vulnerable, and control over them, or the ability to disrupt them, is already shifting underwater.
The only question now really is, who's getting there fast enough to shape what happens next? Who holds the future of the deep? This brings us to our final, maybe overarching question. Who's winning the ocean tech race?
Well, every single deep-sea robot, every innovative sensor, every new submersible, it all starts with a human idea, right? Someone imagining, designing, building something to survive and operate where people just can't. And right now, the country supporting those people the most, the one pouring serious, systematic resources into ocean science and technology, appears to be China. They are building new, state-of-the-art research labs, funding full-scale, ambitious programs, and proactively training the next generation of ocean engineers, marine biologists, roboticists. This looks like a multi-decade national strategy.
Yet you see this clear, relentless, and highly coordinated pattern emerging. A national effort that's really unlike anything we've seen before in the history of deep-sea exploration. And they're not just investing in their own talent. They're actively trying to attract top minds from around the world, offering pretty unparalleled resources and opportunities to accelerate their progress, effectively creating this global brain trust focused on the deep.
Meanwhile, in really stark contrast, countries like the U.S. seem to be pulling back. While China is flooding its labs with money, talent, and momentum, science budgets in many Western nations are getting cut or, at best, stagnating. The current U.S. administration, for example, has proposed significant cuts to funding for NOAA, that's the National Oceanic and Atmospheric Administration, the very agency responsible for exploring, protecting, understanding U.S. ocean territory, and frankly, for maintaining America's scientific leadership in the marine domain.
It's a stark, almost alarming contrast, isn't it? Top scientists, experienced engineers in the U.S. are reportedly walking away from deep-sea research. Not because they've lost interest or passion, but simply because the funding is gone, or the opportunities for sustained cutting-edge work are just diminishing. When funding dries up, crucial research just stops. Valuable data isn't collected, expertise is lost. This creates a vacuum, right? A void of capability and knowledge that will inevitably be filled. And China seems strategically positioned to be the one filling that void.
What's truly fascinating here is the sheer asymmetry. One nation is systematically investing in the future of the deep, flooding its labs with money, talent, strategic momentum, while another seems to be sidelining the very agencies built to compete and maintain leadership. This creates a vacuum that China is readily exploiting. They aren't just exploring, they seem to be positioning themselves to dictate what happens next in the deep ocean, effectively writing the rules for this new frontier. They've discovered a way in through advanced robotics and a compelling reason to stay, driven by resource needs and geopolitical ambitions.
They're transforming deep-sea exploration from these rare individual missions into a scalable, repeatable strategy. Using compact, autonomous robots, planning permanent underwater research stations, they're building the foundational infrastructure to operate consistently where few others can, mastering these incredibly difficult engineering challenges. And they've uncovered resources that could potentially power the next century. But maybe even more importantly, they're developing the tools and the operational experience needed to control access to these critical resources and to influence the undersea domain itself. They're not just exploring, they're positioning themselves to dictate what happens next under the ocean floor.
So while the U.S. potentially cuts research budgets and risks pulling back from ocean science leadership, China is surging ahead faster, deeper, and with what looks like a comprehensive long-term plan. Beneath the waves, a new frontier is rapidly taking shape, one that could profoundly define the century ahead in terms of resource control, technological advantage, and strategic influence. The countries that are investing now in hardware, in fundamental research, in people, and in sustained presence, they are setting themselves up to control what lies beneath. What we collectively choose to explore, and how we choose to do it, will shape more than just our oceans. It's going to shape power, security, and global influence for generations.
Yeah, this deep dive really shows us the immense potential, but also the, frankly, terrifying risks that lie beneath the waves. The deep sea is one of Earth's last truly wild and untouched places, and its ecosystems are incredibly fragile. Once it's disturbed, there might be no going back. The damage could be permanent.
Rushing in without robust international oversight, without comprehensive scientific understanding, could wipe out entire ecosystems and trigger unintended consequences we just don't yet understand, with impacts potentially on the entire planet.
You know, we have been here before, in a way. Think about the race to space. Initial competition eventually gave way to profound collaboration in some areas. The International Space Station, for example, stands as a testament to the idea that nations can work together to push boundaries and protect what matters for all of humanity. We might need to recapture that kind of mindset again, not just to explore the deep, but crucially, to protect it as a shared heritage.
Because if only one nation controls the last unexplored part of our planet, if only one nation holds the keys to its resources, its scientific mysteries, its strategic pathways, the cost won't just be scientific or environmental. It could be something we all feel, a fundamental shift in global power and security that impacts every single one of us. So, okay, we've traveled from the utterly alien world of the Challenger Deep, met creatures straight out of a sci-fi novel, uncovered vast strategic resources like fire ice and polymetallic nodules, and we've seen how one nation is rapidly establishing this unparalleled foothold, developing autonomous robots, planning permanent underwater bases, even creating tools with dual-use potential, while others seem to be lagging behind.
Yeah, the profound implication here is that the deep sea is rapidly transitioning. It's moving from just a realm of pure scientific inquiry to a strategic battle space. The implications for resource control, for technological leadership, even for global communication security, they're not just profound, they are immediate and ongoing right now.
So this deep dive leaves you with a really critical question, one that probably demands global attention. Given the immense power and the potential for disruption that deep-sea technology now offers, how do we as a global community balance the clear imperative for exploration and resource acquisition with the urgent need for ethical stewardship and collaborative protection of Earth's last great wilderness? What do you think needs to happen next in the deep?